Science Easy Tech channel. In this video, we are going to discuss about frequency distribution or frequency distribution table, which comes under Unit 7 in the subject Nursing Research and Statistics. This video will be useful for Bsc Nursing students, post-basic Bsc Nursing students, MSc Nursing students, as well as students who are studying statistics. Before moving on to the topic, if you are new to Science Easy Tech channel, just take a moment to subscribe our channel and also to press the notification bell icon in order to get connected with our latest updates. Let's move on to the content what we are going to discuss in this video. So in this video, as I have told earlier, we are going to discuss about frequency distribution or frequency distribution table for grouped and ungrouped data. What is frequency distribution? So frequency distribution is a statistical method for summarizing the data. So if you want to summarize the data in statistics, you will be arranging the data in an orderly form in order to do the computation very easily and also for better understanding. So for that purpose, you have to arrange the statistical data in an orderly form. So this is called as what? Frequency distribution. When the data are grouped into classes of appropriate size indicating the number of observations in each class, we get a frequency distribution. So first what you will be doing, you will be arranging the data with the desired classes or class intervals, and the data whatever falls into a particular class, you will be tallying it or you will be grouping it in that particular class. That comes under number of frequencies. So this will be more clearly explained as I will be showing the tables. That time if I am explaining, you will be having a better understanding. So a statistical data consists of a list of numbers related to a research. Among those numbers, few may be repeated twice or more than twice. So in a statistical data, some numbers will be repeated twice or more than twice. So the repeating numbers in a data is called as what? Frequency. That frequencies are listed in a table which is known as frequency distribution table. Sometimes in a given data, some values will be repeated, which is called as what? Frequency. And that frequency you are representing in a table, no? So that is called as what? Frequency distribution table. Let us see the objectives of frequency distribution or frequency distribution table. So what are the objectives? To estimate the frequencies of population. So you can identify the how many times the values have been repeated, the frequency of the population. To facilitate the analysis of data, as I have told earlier, for computation of data, if you are going to arrange the data in an orderly systematic form, it will be very easy for you to calculate the data. To facilitate computation of various statistical measures. So you know various descriptive, inferential statistics, mean, median, mode, chi-square test, parametric, non-parametric test, t-test, like that and all, no? So that and all will be very easy if you are going to arrange the data in a frequency distribution table. So these are all the main objectives of frequency distribution table. Next we will move on to the components of frequency distribution table. So under that you have so many components. The first component is class, the second component is class limit, the third component is class mark, fourth component class interval, fifth component class boundaries, sixth component class frequency, and seventh component is tally mark. Let's see one by one. So first what I have told, yes, it is class. So class means you are dividing the data into various classes. You are dividing that given data into various classes based on the given number of data or observations. Sometimes you will be having 5 classes, sometimes you will be having 6 classes, sometimes you will be having 10 classes. Like that, when you are dividing, no, the class interval, for example 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. In such cases, you will be having 6 classes. Okay. So the groups will be divided according to the size of the data. Next is class limit. So the smallest limit as well as the largest limit, whichever is possible. So lower limit, upper limit. So in class limit, the lower limit and upper limit. So for example, the data they have given, no. So for example, 0 to 5, lower limit is 0, upper limit is 5. So like that, no, the given data as a whole, for example, if 60 observations, you are doing 0 to 5, 5 to 10, 10 to 15, then 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55. Like that, if you are doing, so 55 is going to be the last limit and 0 is going to be the lower limit. Okay, but in a particular class interval, for example, 0 to 5, 0 is the lower limit and upper limit is 5. So class mark. So what is the class mark is here the lower limit plus upper limit divided by 2 is your class mark. For example, think of a class interval 10 to 20. Lower limit is what? 10. Upper limit is what? 20. 10 plus 20 divided by 2, which is equal to 30 divided by 2. So 30 divided by 2 is 15. So 15 is your class mark. Class mark is nothing but the middlemost value of the class interval. Okay, next is take the class interval 15 to 20. So 15 to 20, the lower limit is 15, upper limit is 20. So 20 plus 15 is 35, divided by 2 is 17.5. So in between 15 and 20, the middle value is also 17.5, which is your class marker. Next, moving on to class interval. So class interval is upper limit minus lower limit is your class interval. What is the upper limit for a class interval? 20 to 30. Yes, the upper limit is 30. What is the lower limit? The lower limit is 20. So 30 minus 20 is how much? 10. So 10 is your class interval. Next is class boundaries. So class boundaries are nothing but from where to where the class is starting. For example, if you are framing a class interval from 0 to 100, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. So your boundaries lies between 0 to 100. So that is your class boundaries. Next is class frequency. The number of observations falling in each class. For example, 0 to 10 0 to 10 classes, some 4 observations have been forming in that particular class. Means by using tally you will be making the observations. So 4 observations falls in the category 0 to 10. For example, the number of students who are falling under the category of 150 to 160 centimeter height. So in a class 150 to 160 centimeter of height students are 6 members. So 6 members fall in that category. Okay, next is tally mark. So tally mark helps in computing the number of observations. So in binary fission and all you will be learning, no, for 1 you 2 3 4 and for 5 you will be doing like this, no. So like that, for tally marks you have to put strokes against each frequency observed. So here there is an example for a frequency distribution table. So for frequency distribution table, they have given the classes 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Under 10 to 20 you are having two values. Under 20 to 30 you are having 5 values, and under 30 to 40 again you are having 5 values, and 40 to 50 you are having 4 values. So here take the thing, you can take anything. So here they have told 40 to 50, what is the lower limit? 40. What is the upper limit? 50. Okay, what is the class mark? 40 plus 50 divided by 2, 90 divided by 2 is 45. So 45 is your class mark. What is the class interval? Upper limit minus lower limit. 50 minus 40 is equal to 10 is your class interval. Okay, so like that for each and everything also you can find. For example, for 10 to 20, what is the class mark? 15 is the class mark. What is the class interval? 10 is the class interval. What is the lower limit? 10. What is the upper limit? 20. Okay, so here you can see the frequencies, how much falls under each category. So that 2 can be represented as 2 lines. Okay, in binary thing we have already learned about tally. Okay, next, so 5 observations is represented as like this. Okay, then 4 observations is represented as like this. Okay, so this is an example of frequency distribution table. Now we will see separately frequency distribution table for grouped and ungrouped data. So first is frequency distribution for grouped data. So grouped frequency distribution is based on classes forming frequency distribution table. From the following data, construct a grouped frequency distribution. So they have given the data. Using this data, you have to construct the frequency distribution table. So here 3, 8, 5, 2, 15, 16, 13, 12, 10, 9, 18, 11. So this is the given data. So if you want to group the data, what you have to see? You have to see the lowest most value. What is the lowest most value? 2. What is the highest value? 19. So this gives you an idea from where you have to start the class boundaries. So you can start the class boundaries to know. So you can start from 0 and 19. So you can complete with what? 20. So here I have formulated 4 classes: 0 to 5, 5 to 10, 10 to 15 and 15 to 20. So like that you have formulated the classes. Now what you have to do? So each value where it comes you have to see. So 0 to 5. 3. First value is 3. Where it falls? Yes, it falls in the first thing. Next is your 5. So 5 where it falls? Yes. Next is 8, not 5. Next is 8. So 8 falls where? 8 falls in the second category. So tally you are putting in second category. Next 5. You have a doubt whether 5 you have to plot in first thing or second thing. So the uppermost value in class interval is not plotted in that first thing. See here you should not plot 5, but here you have to plot 5. So in the second thing plot 5. Next is 2. 2 you will be plotting in the first thing. Next is 15. 15 also no, you should not plot in the third thing. You should plot in the fourth thing. Okay. So next is 16. 16 also in the last thing. 13. 13 in the 10 to 15 class interval. 12 also in the 10 to 15 class interval. 10 also you have to plot here only. Then 19 you have to plot in the last. 18 you have to plot in the last. And 11 you have to plot here. So here you can see 2 observations has been seen in 0 to 5, 5 to 10 also 2 observations, 10 to 15 4 observations and 15 to 20 also 4 observations. So totally you have 12 observations. 1, 2, see here you have 12 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that you have got it. So you have plotted it correctly. So next is frequency distribution for ungrouped frequency distribution. So the data, you will not group the data, but individually you will be seeing how many times the number have been repeated. For example, in the given data 11, 12, 5, 3, 11, 13, 17, 13, 5, 5, 11, 5. So here write the numbers, each number in ascending order. So first you have taken 3, next highest number is 5, next is 11, next is 12, next is 13, next is 17, the last number is 17. So first what I have told 3, how many times 3 has come? Only one time. Next 5, how many times it came? 1, 2, 3, 4. So 4 times it came. So you have to write 4. Next is 11. 11, how many times it come? Yes, 11 has come 3 times. Okay. So 11 you have to plot it as 3. 12, how many times it came? 12 only one time. 13, how many times it came? 13 here once you are having twice. Okay, so 13 is twice. Next 17, how many times it came? Yes, only one time. So next is types of class intervals. So under this class interval you are having exclusive type and inclusive type. So exclusive type, so there are no gaps and it is continuous. So here in exclusive type, so here the data is arranged continuously. For example, 10 to 20, 20 to 30, 30 to 40, 40 to 50, everything has been included continuously. And here the upper limit of the class interval should be considered in the next class interval. That's why in previously also I have told, if 0 to 5, 5 to 10, if 5 comes means you should not include in 0 to 5 class interval, you should include where? In 5 to 10 class interval. That only they have explained. The upper limit of subclass interval will be considered to the next subclass interval. For example, here in 10 to 20, if 20 comes means you should not include in 10 to 20. Instead of that, you should include where? In 20 to 30. Similarly, in 20 to 30, 30 the value comes means you should not include in 20 to 30. Instead of that, you should include in 30 to 40 class interval. Okay. So this is called as exclusive type. So in exclusive type, you are excluding the upper limit of that particular class and you are including in the next class interval. So but inclusive type, both the numbers, both the upper limit and lower limit will be included in the same class interval. For example, 10 to 19, 10 to 19, 20 to 29, 30 to 39. So here 10 also should be included in the same class interval and 19 also should be included in the same class interval. So this is called as what? Inclusive type. But sometimes you may have a doubt. Suppose if the observation is 19.2, 19.5, 19.8, where you will be including 29.5. Like that and all, if it comes means where you will be including. So for that purpose, we can convert the inclusive type to exclusive type by doing a correction factor mechanism. So correction factor is used, for example, in table 20 to 29, 30 to 39, 40 to 49. So correction factor is used 20 to 29, 30 to 39, 40 to 49. So here, for this given example, how you have to formulate the correction factor? Find out the formula is lower limit minus upper limit divided by 2. What is the lower limit or what is the upper limit? Minus 2. So lower limit, upper limit, same class interval you should not take. So lower limit of second class interval minus upper limit of first class interval divided by 2. So here in the above example, what is the lower limit of second class interval? Yes, lower limit is 30. What is the lower limit of second class interval? 30. What is the upper limit of first class interval? 29. So 30 minus 29 divided by 2, which is equal to 1 by 2, which is equal to 0.5. So correction factor is used, for example, in the above table. What is the lower limit of second class interval? 30. What is the upper limit of first class interval? 29. So 30 minus 29 divided by 2, which is equal to 1 by 2, which is equal to 0.5. So what you have to do? You have to add 0.5 to the low upper limit, and you have to minus zero point 0.5 to the lower limit. So add 0.5 to the upper limit, and you have to subtract 0.5 to the lower limit. So this correction factor should be added to the upper limit of the first class interval and subtract the correction factor of zero point 0.5 to the second class interval lower limit. So the table becomes 19.5 to 29.5, 29.5 to 39.5, 39.5 to 49.5, like that it goes off. So here now that inclusive type has become exclusive type by using this correction factor. Hope this video has given a detailed explanation about frequency distribution table. So once in university question paper they have asked about frequency distribution table in 5 marks. So this video is more than enough for a 5 marks question. If you like my video, please give a thumbs up, share and subscribe to Science Easy Tech channel. My previous videos link I have given in description box, suggested end card, iCard and description box also. So you can watch our channel playlist for more nursing research and statistics related videos. Thank you friends. Keep supporting to Science Easy Tech channel.